Okay, our next question is a really solid A star topic that we need to look at really carefully. Now it's A star because it links lots of areas of maths and it's probably going to be a multi-step question. It's going to be about 4 or 5 marks that you're going to have to tackle on your own. Now we're trying to find out the surface area of a pyramid. Now first thing we need to understand, the surface area is the space around the outside. So in this square-based pyramid, our surface area will be our 4 equilateral triangles, our isosceles triangles, with one square at the bottom. So we need to work out the area of all of those. Now the square is easy, we can see that already, that's 4 times 4, but we have to try and work out the area of these isosceles triangles. Okay, so let's look at one of those isosceles triangles. Well, we know so far that the base of our isosceles triangle is 4, but we don't know the height, because you notice that the height here is slanting, and we only know the vertical height, i.e. the distance from the top of our pyramid to the base. Now that is not the same as the height of this triangle because it's been slanted. So what we need to visualize here is if we take a slice of that pyramid right down the middle, and we see this triangle here. Okay, now we know the vertical height of that, we know the base of that, and we can use that to find out the slanted part, which is of course the height of this triangle here. So let's have a look at that. Here we go, there is that orange triangle, and we see it's got a base of 4, it's got a height of 7, and this length L here, that is the height of this triangle here. Now hopefully you've noticed that we've got a right angle triangle where in fact this length here is 2, okay, and this length here, we already know that, that's 7. So it's a right angle triangle where we know 2 of the sides, so we can use Pythagoras' theorem to find the other side. Now Pythagoras' theorem says that a squared plus b squared is equal to c squared, where c, I'm going to change L to c for the moment, is our longest side, our hypotenuse. So let's put those values in. So a will be 2, so we've got 2 squared, plus b, which will be 7, plus 7 squared is equal to c squared. So we get 4 plus 49 equals c squared. 53, when we add them together, we get c squared, and therefore c is the square root of 53, which to 2 decimal places is equal to 7.28. So there's our value c. So that, our diagonal length here, is now the height of this triangle here. So it's 7.28. Now we should be happy with that answer because it's definitely going to be longer than 7. 7 is the vertical distance, and we're slanting it, so it's going to be a longer distance. 7.28 looks like a good number. So the area of our triangular face we can now work out with the formula for area of a triangle, because it's a half times the base times the height. Put that into your calculator and you get 14.56 centimetres squared. So let's finish off this question now then, come down to the bottom. So our total surface area, which we said at the start was the 4 isosceles triangles, so it's 4 times the area of each triangle, plus the area of the base, and we said that was a square, so that's 4 times 4. Put all of that into your calculator, and to 1 decimal place you'll get the answer of 74.2 centimetres squared. So lots to take in there. Okay, so quick recap. Surface area is the space around the outside. That's 4 isosceles triangles and 1 square. The square is easy, but to find out the area of the triangles we need to know this length here, this diagonal, and we can do that by taking a slice in the middle, and we see we get a right angle triangle where we know the height, we know the base, it's half of the total base of the square. Use Pythagoras to find that, use that to find the area of the triangle, and then find the 4 triangles plus the square, and you get your final answer. So lots to take in. Hopefully that makes sense.